Hi, welcome to video 4 of the online Basys Training, presented to you by QED, the actuarial arm of Aon Hewitt. The videos are aimed at a fairly basic level to get you started and more comfortable with the software package, but can be used to consolidate some of the knowledge you already have about Basys. This video will explain a little more about the main output that Basys will produce, as well as provide some more insight into the more frequently encountered fatal errors. Let's get started. So far, we have explained the setting up of all the necessary sections of the parameter file and the databases, pulling them together and performing the required run in the control file. Depending on the type of run you performed, the most important thing that you will likely be interested in is the output that Basys produces. The first thing to note is that all the output that Basys produces comes in a comma-delimited format. Although some of the output can be viewed directly in Basys, the best way to view it is using Excel or a similar spreadsheet software package. The second important thing to know is that Basys works on garbage in, garbage out. This means that Basys will do all the necessary calculations with the parameters and numbers that you give it, and if these values are incorrect, then Basys will give you an incorrect output. Therefore, one of the most important things to do is to check that Basys is viewing and calculating a product as you think it should. The .det file is one of the most important outputs and can be used for this confirmation. A .det file gives detailed output showing the cash flows generated by Basys in its calculations for specific policies. For any run that makes use of cash flow projections, detailed output can be given. This will be carried out for the first policy of every policy type and every X policies thereafter as defined in the control file. In this example, the first and every 10th policy will be shown. No detailed output will be given if this option is set to 0. Detailed output gives a complete set of undecremented cash flows. Let us use Excel to open an example. As you can see, all Basys output will start with a header detailing some of the specifics of the run. The important information here will be the Basys version number, the type of run, and the file path of the data and parameters. Then, immediately after the header in the .det file, Basys will provide information directly relating to the policy it is detailing. This will include the policy number and type, as well as items of interest such as office premium and sum assured. This is then followed by the cash flows. The rows will show the progression of time in months, and the columns show the particular cash flows of interest. Non-unit cash flows will be shown first, followed by any probabilities relating to the policy as well as some results. And then, if appropriate, unit cash flows will be shown. The next output of interest that will be produced is the .sum file. This output will be generated when you select the Automatically Create a Summary File option. As the name suggests, the file is a summary of the reserves and other results. These results are totaled and split by policy type. As with the .det, the initial header shows general information about the run that produced the summary. It then also shows the information summarized from the run. The first few columns show information taken straight out of the data, such as total premium and total sum assured. The later columns show the calculated results. These results shown vary depending on the type of run, but can include present value of premiums, present value of sum assured, reserves, and value of in-force. Another important output is the .mod. This gives the projected accounts of the various model account runs, and hence it is only produced when running one of these runs. The general information will be shown first, as with the other output. The decremented cash flows are then broken down for the income statement and the balance sheet items. The income statement is shown first in the rows, followed by the balance sheet items. The passage of time is shown across the columns. The grand total will be shown first, which sums all the policies in the database that was used, after which a breakdown per policy type will be shown. Other output files of interest that we won't go into much detail here include the .par, .psu, .rte, and .fat. A .par records details of all parameters and decrement tables that were defined in a parameter file that was used in the run. A .psu shows the results of the premium rating run. The .rte shows a summary of the runtime warnings and errors that occurred during the run. The .fat shows a summary of all the fatal errors that occurred during the run. A fatal error is a serious error that occurs during a run. They can result from a number of factors, and we will discuss some of these factors now. One of the more common fatal errors is empty database or policies without parameters. This, as the name describes, is telling you that Basys cannot find a match between the policy type in the parameter file and the policy type in the data, and hence considers the database to be empty. Another instance of this error occurring is when Basys is looking for in-force policies and the database only has movement policies in it, or vice versa. Survival errors are another common fatal error. This error occurs when one of the survival probabilities is pushed outside the bounds of 0 or 1. It is common that a combination of the decrements applying to a policy and its withdrawal rates are pushing it over the boundary. It can usually be resolved by examining the .det file. Automatic summary crashed is a fatal error that occurs when the .sum file cannot be created. The easiest way to find the cause of this error is to create the .sum file manually, i.e., open the database, summarize, and save the results. The biggest reason for this error is large databases being run on a PC without sufficient memory to handle them. Iterations exceeded is a fatal error that occurs during a premium rating run, where Basys cannot find a solution to the run within the given number of maximum iterations. Note that this number can be changed by going to Options, Setup, in the control file. For help on any other errors, please try and access the Basys help. This can be done by pushing F1 anywhere in Basys. That is a brief introduction to the Basys output and some of the more common fatal errors. Please continue to our next video for a full example of setting up and running a control file and its individual components. Thank you for tuning in. Goodbye.